Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will do a homework problem from section 6.5. This problem talks about the amount of weight that a plane can take when there are a plane full of men whose weights are normally distributed with a mean of 178.1 pounds and a standard deviation of 36 pounds. Basically, the summary here is asking the probability that an aircraft is overloaded, and the aircraft is overloaded if the mean weight of the 37 passengers is going to be bigger than 164 pounds. So let's take that information onto our Google Docs, and the summary is that the men's weights are normally distributed. We have the passenger load total, a maximum of 6,068 pounds. We have 37 passengers, and so we want to make sure that the mean weight is going to be not greater than 164 pounds. The question was, find the probability that the aircraft is overloaded. Another way to restate that in this particular problem is find the area under the normal distribution where 37 passengers have a mean weight that is greater than 164 pounds. Just to remind you, our formula is the normal distribution formula. So we will type equals NORMDIST. That's a normal distribution. We want to check our weight with 164 pounds, and our mean is given by 178.1, and now our standard deviation, we actually have to update our standard deviation, so I'm going to leave this formula. It's going to give me an error right now, and I'm going to go back to this and say we want our standard deviation for 37 people, and according to the standard the central limit theorem, our standard deviation will be our old standard deviation divided by the square root of whatever our sample size is. In this case, it's going to be 37. So this is going to be our new standard deviation. Now back to this formula. I was in the middle of typing that in when I didn't have my standard deviation, but now I have the x value, which is 164. I have the mean, and then the standard deviation is going to be the new standard deviation. And then should this be a cumulative distribution, I'll say true, and this is what I get. Remember that this gives you the area to the left, and area to the left is less than, so we want the actual probability where we're looking at the area that accounts for the weights that are greater than, and that is just a complement, so we will say equals 1 minus and then that previous answer that we got. So this is a 99.027. Probability is 0.99027. Round out to 4 decimal places, that will just be 9903. So that's a pretty big probability. Should the pilot take any action, it looks like the probability is high, and that's not a good thing. So the pilot needs to get rid of a couple of passengers just so his payload will not be over 6,068. Okay, that looks good. I hope that helps.